Hi guys, this video is for 5.3. Okay, this is truly a review from last year. Last year you guys already graphed log functions and exponential functions. So this is just a quick review. Okay, so we will going to go quickly through this section. Okay. So just a review for you, properties of the exponential function. Okay, so the exponential function, oops, I meant highlighter. It's f of x equals a to the x, where a is greater than 1. So a quick example, it's i.e. f of x equals, let's say, 3 to the x power. Okay, your a is 3, and that's definitely bigger than 1. The domain, it's all real numbers. Okay, so the set of all real numbers. The range is the set of positive real numbers. What does that mean? How do we write that? So the domain is going to be from negative infinity to infinity. The range is going to be positive. So that means it's going to be non-including 0, okay, all the way to infinity because it needs to be positive. So look at this picture. The range is just from 0 and up, not including 0. There is one x-intercept. Okay, and there's one y-intercept, no x-intercept. There's one y-intercept, and the y-intercept is at 1, which another way we can write that is 0, 1. Okay, you do have a horizontal asymptote. Oh my, okay. Your horizontal asymptote is y equal to 0. That means you have this dashed line right here on the x-axis. Okay, then because a is greater than 1, it's going to be an increasing function, okay? And it is 1 to 1, okay? Increasing, if you remember, increasing meaning that if I keep going positively in the x direction, okay, y is going up. That's what it means to be an increased function, okay? The graph of f contains 3 points. And yes, these are the 3 points I want you to use every time we're graphing using transformations, okay? So when x is 0, so let's use the IE example that we have. When x is 0, okay, 3 to the 0 is always 1. Any number raised to the 0 power is always 1. When x is 1, 1 is now my input. 3 to the 1 is still 3. So that's why a is your base. Then when x is negative 1, okay, 3 to the negative 1, which is class, that's the same as 1 over 3. So these are the 3 points that you will be asked to start out with, okay? A is your base. So a is the base of your exponential function. The graph is continuous and smooth, okay, with no corners or gaps. So as you can see, no holes anywhere. You can graph it continuous, meaning you can graph it from beginning to end without lifting up your pencil. Now, what happened when a is not greater than, okay? What happened when a is not greater than 1, but not less than 0 either, so keep that in mind, okay? So this piece is important. A is not negative. Okay, but it's not greater than 1. So an example, a good example would be like 1/5. Okay, that's my a to the x value. This is your base. Okay, base is 1/5. Your base is 1/5. Okay, so with that in mind, let's look at the domain. The domain is still all real numbers. The range is still positive real numbers. Okay, so those are not really changing from the top where a is bigger than 1. Again, no x-intercept, but the y-intercept is still 1. That it's the same. You still have a horizontal asymptote at y equals to 0. Okay, this is changing. Okay, this is the part that's changing because a is in between 0 and 1. It's a decreasing function. So check as you are going to the right positively. Okay, y is reducing, okay, so that's why this is decreasing. And again, your graph will contain the same 3 points as earlier, except, okay, so let's use our 3 points, okay? When x is 0, okay, and again, 1/5 to the 0 power is 1. Any number raised to the 0 power is always 1. When x is 1, 1/5 to the x is now 1/5. So notice how that is different. Then 1x is -1. So what's happening is you have 1/5 in quantity raised to the -1, which means this point is really -1. And what happens to that fraction? You would flip it. Okay, so now it's 1/5. Okay, so now it's no longer 1/5. It's actually -1, 5. So if you look at this, it's always flipping your base. Whatever your base is, you're flipping your base. Okay, my base is 1/5. So when I plug in -1, I flip 1/5. So now it is 5. Okay, and number 6 is the same. Okay, it's still smooth and it's still continuous, and I can still graph it from beginning to end without lifting up my pencil. Now we're going to try to do example 2. Example 2, use transformations to graph each. Determine the domain and range. State the horizontal asymptote. Now, the first 2 units of the semester, you were asked to do one graph at a time. Congratulations, you only have to graph the final answer, okay? But you are to do the stages one stage at a time. We just don't need to graph them out. So just kind of saving you a bit of time. So we are going to start with the parent. Okay, so this step is the same. F of x equals 2 to the x. And you are going to require points. Okay, require points are the 3 points from the chart above. When x is, okay, let me flip it back up. When x is 0, when x is 1, and when x is -1. So 0, 1, and -1. And you have to use these 3 points to continue, okay? So when x is 0, 2 to the 0 is always 1. When x is 1, okay, 1 is your exponent, so 2 to the 1 is still 2. When x is -1, if you look at the points, whether it's decreasing function, increase function, you flip your a, right? Your a in this case. So this is really going to have your a, which is your base, and your base is 2. So if you flip that, it's now 1/2. Those are the 3 points. Okay. Next, you have this equation, y equals 2 to the -x. Okay. Transformation-wise, this is going to be a reflection over. Okay, this is the part where some of you are going to be confused. It is with the x. Okay, so remember, anytime you have it with the x, it's a reflection over the y-axis. Okay. Okay. What does that really mean? Formula-wise, y-axis, okay, so let's say that you have something over here. I am reflecting it over the y-axis. Now it should be over here. So the x value is the one that is actually changing. So I'm really formula-wise, this is what I'm doing. I'm changing all my x's, okay, and keeping y exactly the same, okay? But here's the beautiful part now that you don't have to graph it in stages. I can just go and do the next one. Y equals 2 to the -x minus 3. This is a down by 3. So formula, down by 3 means, hey, you know what? I'm going to subtract it from the y. So this is what you are going to use or can use to get your final points for the final graph. Isn't that beautiful? Okay, whoa, right there, okay? So these are the parents. Okay, you're using these 2 highlighted parts to put together the final 3 points, okay? Final 3 points. Okay, here we go. I need to change all my x's. So I've got 1 point, 2 points, and 3 points. So it says -x. So if it used to be positive, it is now negative. If it used to be negative, it is now positive. Then it said y. How am I changing my y? I am going to -3. So 1 minus 3 is now -2. 2 minus 3 is now -1. Half minus 3 is now -2 and a half. So I'm going to plot those, okay? So 0, 2, 0, -2, -1, and -1. And then 1, which is now -2 and a half. Okay, I have 3 dots. What is it going to look like? Well, it's going to look like this. like that, okay? Well, then you're going to ask me a question. Well, isn't A 2? Isn't 2 according to a bunch of writing up here? When A is greater than 1, shouldn't it be a increasing function? True, okay, but what's really happening is this value, this guy right here, f of x equals 2 to the negative x plus or minus 3, okay? Guys, you know what happens when you have a negative power? That's like flipping it. That's like this, okay? So if I were to have a positive exponent, my base is really now a half, okay? Because base is at a half. Half is in between 0 and 1, so that's why it looks like a decreasing function. Now, what is it that I'm missing? That's super important. I need to identify my asymptotes, okay? It used to be at 0, okay? So the asymptote used to be at y goes to 0, but because we shift it down by 3, so the asymptote is now at y equals to 3. And yes, you have to graph that there. So, okay, so if you look at it, we are doing this graph by transformation a lot faster than what we are used to, okay? So if you are confused, then just do it old school and put the final graph on here. So we did it all, okay? We graphed it out. We state the domain. I'm sorry, we did not state the domain. I meant to say we state the horizontal asymptote. So now we have to state the domain and the range, okay? The domain of all exponential function class is always all reals. The range, according to this, is from 3 all the way to infinity. We box that up. Okay, state domain and range, we graphed it out. Beautiful. So if you are super comfortable with graphing it this way, you are okay now to do it this way. If you are not comfortable, you can graph out the first 2 stages and do it like the way that you used to, and then just put the final graph on here. Okay? Let's do it here. Example B. I'm going to start with the parent. Okay. Then the parent is f of x equals e to the x. My 3 points are 0, comma something, 1, comma something, negative 1, comma something. Okay. So when I plug 0 in, e to the x is e. Okay. And just to give you a heads up, e, it's about 2.718. Just like pi, it's about 3.14. So e is an actual value. It's an irrational value. It's a constant, so don't be scared you see e. Next, I think I just there. Sorry. E to the 0 is 1. And then when input is 1, e to the 1 is e. When I plug in negative 1, e to the negative 1 is 1 over e. What does it really mean to have 1 over e? 1 over e, it's about, okay, 1 over 2.7-ish, which is, if I need to make an estimation, okay, it's about 1/3. So really think about it that way. Obviously, it's not exactly 1/3, but if I just need to make an estimated so I can plot, then you can think of it as a 1/3 distance, okay? You have a few transformation, okay? So f of x equals negative e to the x. Guys, this is a reflection over x-axis, okay? What does that mean? That means all the y values are changing, okay? So it's going to be a negative y and x stays the same for my parent. Then the next one, f of x equals, I did the negative e already, it's minus 3. It is with the x, so I'm going to go right by 3. So if I go right, now I would add 3 to 2x. So here is the final equation. So because it's a final equation, I need to use my parent point and follow through. So 0 plus 3 is now 3, okay? 1, it's my y. It's multiplied by negative because I need to change it. So now it's negative 1. So that's my new point, my final point there. Then I have 1 plus 3 is now 4, okay? Then e is now negative e because I have to change my y. Then I have negative 1 plus 3 is now positive 2. That's going to be now negative 1 over e. So these are my main 3 points. I used to have an HA. Okay, I used to have an HA of y equals to 0. My HA is really not changing. I'm still going to have it at y equals to 0. So, because I'm not going up and down. So, HA is still at y equals to 0. Okay. It says I'm reflected over x-axis, so now I am expecting it to look upside down. Okay. So, 3, comma, negative 1. 4, negative e. So, here's 4. Negative e is about 2.7. So, somewhere in between negative 2 and negative 3 is perfectly okay. 2 and negative 1 over e, okay, and we mentioned before, 1 over e is, think of it as about 1/3. I'm not going to hold you to it if you're not plotting it exactly at 1/3, as long as in between 0 and 1, you know, plot. Graphing by hand is never perfect, you know that. And so as long as you plot those dots, okay. All right, so these are the points that are required. You have the asymptote, you have the graph. You now ask to find the domain and range. The domain of any exponential function, it's always all real. The range is interesting. It's going to be from negative infinity to 0 since we reflected it over the x-axis. Okay. All right. We have one more example. We have example C. This is going to be the last one for today. This one has a base value. Ooh, A is 1/4, okay? That means your base is in between 0 and 1, okay? So without any transformation, you're gonna expect it to be a decreasing function, okay? Just like this one. But let's see. All right, with transformation, it might change a little bit, but who knows until we have really graphed it out. Parent, f of x equals 1/4 to the x, okay? You're going to need your 3 points. You're always going to use 1. You're always going to use 0. You're going to use negative 1, okay? So 1/4 to the x is going to be 1/4. 1/4 to 0 is going to be 1. Negative 1 is my input. 1/4 to the negative 1. You flip it, so now it's 4. So that's the parent function. The nice thing about this is that you only have one transformation. Okay, so let's just write our HA down. Y equals to 0 originally. So your one transformation is f of x equals 3 times 1/4 to the 4th power. This is a vertical stretch factor of 3. Why am I saying to the power of 4? Power of x. Okay. The reason it's a vertical stretch is because it's not with the x-axis. Okay. So, like for example, just kind of off topic, i.e., if I have 1/4 to the 3x, then this is a horizontal compression factor of 1/3. So, because it's with the x. Okay. So that's the difference between when it is horizontal and when it is vertical, okay? All right, since I have it as a vertical stretch, my x maintains the same, the y gets decreased by 3 times. So there's my formula. Original equation. So let's find my points. Ready? 1 point, 2 point, 3 points, box it up. My HA will get multiplied by 3, but 0 times 3 is still at 0. So here is my HA still at the same exact spot. Okay, so graph that out. All right. So take y multiplied by 3. So 1 stays. 1/4 times 3 is now 3/4. 0 stays. 1 times 3 is now 3. Negative 1 stays. 4 times 3 is now 12. So those are my 3 main points. Let's plot it. 1, I'm now going up to 1. Let's see. Okay, I made it too big. I made it too high, I meant. 3/4, 0.75. So somewhere in between 0 and 1 is okay. And then 0, I'm going to go up to 3. There's my 3. Then -1, I have to go to 12. This is a 10 by 10, so I have to make 2 more tick marks, okay? So there is my 12 above the y. So, whoa. All right, so connect the dot nicely. Try to be as, okay, I'm gonna turn my computer sideways. Hopefully it's not gonna turn on you. All right, I missed my dot. Let's just make that fat. All right, make those fat too. All right, make that fat. Okay, there is my graph with a base being 1/4. Okay, I graphed it out. I have my HA. Y equals to 0. The domain is always, what? Always what? All real, for all exponential. The range looks like it is from 0 all the way to infinity. Okay. All right, y'all. That is the end of our graphing part for exponential